Okay, so we're going to talk about the gram redacted process today. Um, should be noted that this is sometimes called the Graham-Schmidt process. Um, Schmidt was a Nazi collaborator, so frankly, fuck that guy. Um, he also didn't do anything to contribute to the math here. So I don't know why his name's on this. I wish it weren't, so I took it off. Graham redacted. Here we go. Okay, so the idea of the Graham process is that what we're going to do is we're going to start with a basis that's not great. Turn a basis, so this is going to be like A1 through AN, into an orthonormal basis. That's going to look like Q1 through QN. Right. I'm not going to change the number of things in this basis, but I am going to make them so that now they're orthonormal. So my process is actually going to be pretty straightforward. This is not something that you're going to want to do by hand, but this is a real chill thing for a computer to do. And having an orthonormal basis actually makes my life real easy. So this is a thing that people end up doing, kind of regularly. Mathematicians do the like say all the time, like, okay, I have a basis. Let me just assume that it's an orthonormal basis because I know that the Graham redacted process exists, right? So we can just go ahead and kind of do that, right? So here's how we're going to do this. Kind of going to be stepwise. So step number one, right? A1 is probably not a unit vector. It is thus far perpendicular to all the other stuff I have in this set. So I'm going to make Q1 equal to A1 divided by the magnitude of A1. Easy peasy, done, right? Then my next thing I'm going to do is I'm going to say, all right, I need to make Q2 equal to, well, this is where things get a little hard. I'm going to take A2 and I'm going to subtract off the component of A2 that's parallel to Q1, right? So if I had to write that out, I'd write it as, well, let me maybe write it here in kind of crayon, right? This is going to be A2 parallel, right, to Q1. Now, this kind of tower of subscripts sort of sucks, so we should probably remember how to project, right? So this is going to be me. I'm just going to pop back, right? I'm going to go back to the idea of projecting generally, and I'm going to grab this guy. Oh, conveniently, I had that highlighted. Okay, so I'm just grabbing this idea of projection. I'm bringing it back here. I'm just going to set it over here. I'm going to turn it frickin' orange or something. And then I'm just going to write recall above it. And this was W parallel, right? So here I just want to make this kind of parallel piece, right? So I need to make a parallel piece. Okay, so I'm just gonna like basically write down some of this. The convenient thing is the vector that I'm projecting onto, right? This Q1, that's the kind of slope I'm projecting onto. Q1 dotted with Q1 is 1, right? So I'm gonna have Q1, Q1 transpose A2, right? And that's going to be me done with that component. And then I need to divide this, and I need to divide this by the magnitude of this whole business. Oh man, I forgot so many vector hats here. Sorry about that. So a whole bunch of vector hats. So I need to divide by the magnitude of the result. So I need to take A2 minus Q1, Q1 transpose A2. Right, so that's just this top vector. I'm just dividing by the length. Okay, great. Done. Now we're going to do step three. Step three is going to be Q3 is going to be A3, right? So we're starting with A3. We're going to subtract off the same kind of thing, right? So we're going to project onto Q1. And then we're also going to subtract projecting onto Q2. Oh God, Joe, your handwriting is terrible down here. Sorry, my hand's just hanging off the edge of my drawing pad, and it's a little hard to write. So Q2 transpose A3. Now, how do I know I don't have to deal with, like, maybe this isn't perpendicular anymore? Well, remember the Q's are perpendicular to each other. So once I've started orchestrating Q this way, I don't have to worry about any weirdo interactions. You could also form up a matrix Q here. And remember that that matrix, that orthonormal matrix Q is going to be easy to project onto. So alternatively, we could kind of make this like Q, I don't know, 2, which is a matrix that looks like Q1 in the first column and Q2 in the second column, right? And then we could subtract off Q2 transpose times A3 here. Either formulation of this will work. It doesn't matter which one you do. And then we just need to divide, and we have to divide by the magnitude of that whole thing. So I'm going to do a dirty trick here and just copy this and paste it over here because I need to delete that thing. Paste that in here. That's the magnitude I need to divide by. Then guess what I'm going to do for Q4? I'm going to do the same thing. So I'm just going to finish this process with dot, 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 and then you're done. And that's what you get. So it's a bit of a pain. It's not real easy, but the computer's happy to do it. And pure mathematicians are happy to say that it can be done. So that's what I want you to take from this. I want you to take the idea that I can take a basis and I can turn it into an orthonormal one. That makes my life a bit easier later. So I want you to know that we can do this. Thanks.